Hello everyone, I set up a little experiment here today to demonstrate surfactant in the lungs. So you remember that surfactant is secreted by the type 2 alveolar cells, and it's secreted to prevent the alveolar walls from sticking together. So water is polar, so if you cough out or you breathe out heavily, the inside of the alveolar walls are going to stick together. That's because water's polar. So it's just like if something sticks to your table when it's wet, type of thing. So if we add a surfactant to the water, it makes the water not polar, and they won't stick together. So that's what prevents alveolar cells from collapsing in your lungs. So we set up a little experiment here today. We're going to put some water on the table here, and our alveolar cell is the perfect push-up here. And since you can tell it's not getting a lot of use from its normal intended use, we're going to make a little experiment out of it here. So here we go. So this is our alveolar cell interface here, so the table and the bottom of this perfect push-up here. So we're going to pour some water on here. This would be like the inside of your lungs here, of your alveolar cells. So remember, they're always moist, always wet. So we get some water on there. Yeah, we'll put a little water in here. And what we're hoping is going to happen when we put these together is they're going to stick a little bit. So that's kind of our intent here. We're going to show that sticking, and I just need to find the rubber band. So, and we're going to measure force here with the rubber band up against the ruler. So we're going to put it like this and pull up on it and see what happens here. So set up my rubber band here. One second. Get it right here. All right. So, got our water on the table. Just look at it against how far I have to pull the top of the rubber band up before this surface picks up off the table here. So here we go. So I'm pulling real hard. I almost broke the rubber band there. So you can see it was well off the top of the ruler here. So I had to pull it a real good ways there. So what we're going to do now is we're going to add surfactant. Now, surfactant in the lungs, again, secreted by the type 2 alveolar cells. It's an emulsifier. So an emulsifier acts to eliminate those polar bonds, and it's going to hopefully make those surfaces not stick together. So when they hit, the lung doesn't stay collapsed, and you don't have that type of collapsed lung. So we're going to shoot a little bit of soap on here. And this also is what gets the oil off your hands. When you wash your hands, you use soap. And the soap emulsifies the oil on your hands and does the same type of reaction. And it mixes that soap up, it mixes that oil up and helps it move it from your hands. So that's dirt is an oily substance. It's hydrophobic, so it doesn't mix well with water, which is why it's hard to wash dirt off without soap. So that's why soap works. So I'll put a little on there, put a little on here, and get a good surface there. And let's try this again here. Okay. So put our ruler back up here, and hopefully this picks up easier here. Let's see what happens. So we were right about 12 inches there when that pulled off. Do you remember last time it was well off the end of the ruler? So it's subtle, but there definitely is a difference there. And my cheap soap that I use here probably isn't the best, but let's try one more time here. So we got a little bit more that time, so we were maybe 14 inches there. Before we were probably about that higher. So you can see that it's doing its purpose there. It's making those surfaces stick together less. They still stick together a little bit, but the lungs probably have better soap than I use. So the same process works in the intestines as well. So we have an emulsifier there that helps break up the bile, which is the emulsifier, helps break up those little fat droplets, and those fat droplets are then easily digested. So that's all I've got for you. Good luck on your test.